You fear the deep ocean, not because of anything you have personally experienced, but because your ancestors encountered its dangers, roughly 400 million years ago. In 2019, neuroscientists identified a primitive fear circuit in the human brain that appears to activate a stress response specifically linked to deep water. Their findings suggest that this neurological pattern can be traced all the way back to the Devonian period. Back then, the oceans were home to a fearsome fish known as Dunkleosteus. Its bite force reached an astonishing 80,000 pounds per square inch, reportedly exceeding the impact pressure of a sniper bullet. Even more alarming, it could snap its jaws open in a fraction of a second, about twice as fast as a human blink. That sudden motion also generated a powerful vacuum-like suction, pulling prey inward before it had any chance to react. In many cases, before you could even register what was attacking you, you would already be swallowed whole. Scientists have discovered fossil evidence suggesting that one Dunkleosteus may have fatally bitten another. Put simply, that seemingly irrational fear of the deep ocean may not be just a modern psychological response. It could trace back to an ancient survival instinct shaped roughly 400 million years ago, and still embedded in our DNA. In a sense, that inherited warning is telling you to stay out of the water. Which leads to an intriguing question: what exactly was this terrifying creature that left such a lasting impression on our distant ancestors? Around 419 million years ago, Earth looked nothing like it does today. At that time, about 85% of the planet's surface was covered by ocean, roughly 15% more than today. If sea levels from that era were applied to the modern world, major cities such as Beijing, Shanghai, and New York would be submerged. The continents, too, were arranged very differently from the way they are now. At that time, Africa did not yet exist as a separate continent. Instead, there was a vast landmass known as Euramerica, formed by what are now Europe and North America connected as one. Meanwhile, in the southern hemisphere, an enormous supercontinent called Gondwana brought together present-day Antarctica, India, Australia, Africa and South America into a single body of land. In other words, much of the planet was arranged very differently from today, making Earth in many ways a genuine water world. Dunkleosteus stood at the top of this ancient aquatic world. Scientists often refer to the Devonian as the Age of Fish, a label that captures the era's explosion of marine life. Yet that name feels far too mild for what the oceans had become. If one were to give it a more visceral title, it might be called the Age of the Ocean Meat Grinder, because the seas of that time produced an extraordinary array of highly efficient predators. Among them, Dunkleosteus was arguably the most formidable and terrifying of all. It belonged to the placoderm group and became the first multi-ton apex predator known in Earth's history. Before its arrival, the largest marine hunters may have weighed only a few dozen kilograms, but with the emergence of Dunkleosteus, that upper limit surged past 2 tons. To put that into perspective, even the heaviest great white sharks alive today reach only about 1.9 tons. In other words, Dunkleosteus likely outweighed even the biggest great white shark ever recorded. Yet, its mass was only part of what made this ancient predator so intimidating. The truly frightening feature was its build. Imagine the protective strength of a tank. The head and entire front portion of Dunkleosteus's body were constructed in much the same way. Instead of being covered in typical fish scales, it was protected by solid bony armor, forming a hard external shield extending from the top of its head down to the front of its torso. This armor can be as thick as 5 centimeters, made from a substance known as dermal bone. It is nearly as hard as human teeth. What does that mean? It means that even if you have a weapon, you still may not be able to pierce it, and even if you somehow do, you likely won't get away, because its speed is faster than you might expect. Using fluid dynamics simulations, paleontologists have found that Dunkleosteus may have been capable of reaching speeds of up to 30 kilometers per hour, around 4 times faster than an Olympic-level swimmer. This formidable predator was also highly adaptable, able to move through both shallow coastal waters and deeper marine environments. Fossil evidence further suggests that its range was extensive, with remains discovered in both North America and Europe. It lived in African waters as well, which meant this formidable predator was far from confined to a single region. No matter where prey tried to escape, there was a real chance of encountering it. Yet, the feature that made Dunkleosteus truly unforgettable was its mouth. You may have heard that Dunkleosteus had no teeth, and that is correct. But that is hardly reassuring. In fact, that detail only makes it more terrifying, because it never needed teeth in the first place. Its upper and lower jaws are shaped into two enormous bony blades, their edges as keen as a pair of scissors. When they snap shut, the motion is less like a bite, and more like a clean, crushing cut. Picture an industrial set of shears nearly 2 meters long, clamping down with pressure around 80,000 pounds per square inch. Under that kind of force, bone, armor, and even hard shells would offer almost no resistance, giving way as easily as warm butter. Researchers carried out a comparative test. A .50 caliber sniper round striking a target exerts roughly 15,000 pounds per square inch of pressure. By contrast, the bite force of Dunkleosteus was estimated to be more than 5 times greater. What does that actually imply? In simple terms, if a Dunkleosteus clamped down on your arm, it would not merely snap it off. It could tear through an arm, down to the molecular scale, and it struck with astonishing speed. In 2006, researchers used computer modeling to reconstruct the bite mechanics of Dunkleosteus. Their analysis revealed a remarkable detail. Its lower jaw operated through a mechanism known as a 4-bar linkage. This mechanical design is still applied in modern engineering, particularly in pumping systems. With the help of this mechanism, Dunkleosteus could snap its jaws open in just 20 to 60 milliseconds. By comparison, a human blink typically takes around 100 to 150 milliseconds. Put simply, before you can finish a single blink, Dunkleosteus may have already struck twice. Yet, its speed is not even the most terrifying thing about it. That explosive speed comes with a powerful consequence. When Dunkleosteus snaps its jaws open in an instant, it creates a sudden low-pressure area just in front of its mouth, essentially a vacuum. The result is an intense suction force that pulls in anything nearby. In other words, when confronted by Dunkleosteus, direct contact isn't even necessary for you to be dragged toward it. As long as you're within 5 meters in front of it, the instant it opens its mouth, you'll be pulled in like something caught in a vacuum, flying straight into its jaws. Then, the bone plates clamp shut. Game over. You might assume a creature this terrifying must have been extremely rare. In fact, the opposite was true. The Dunkleosteus family included more than 10 different species. They were found throughout the world's oceans, and remained a dominant presence for roughly 50 million years, covering most of the Devonian period. Put simply, for tens of millions of years, almost anywhere on Earth, and at nearly any point you entered the water, the odds were remarkably high that you would encounter these heavily armored marine giants. Even more striking, Dunkleosteus was not even the biggest of its kind. Among its relatives was a giant known as Hanosaurus, which could grow to about 6 meters long, roughly the size of an adult killer whale. Some researchers believe Hanosaurus may have been a plant-eating species, surviving on plankton in a way similar to modern whale sharks. Its sheer size alone would have been enough to make anyone's pulse spike, and at that time, the ocean was not ruled by Dunkleosteus alone, as a living nightmare. As mentioned earlier, the Devonian period was essentially the age of the ocean's great meat grinder. Dunkleosteus was only one part of that brutal machine, surrounded by a whole lineup of equally fearsome predators. For instance, Titanichthys was part of the lobe-finned fish lineage, making it a distant cousin of modern coelacanths. This ancient fish could grow to around 4 meters long and weigh more than 160 kilograms, about the same as a full-grown lioness. Yet its most striking and unsettling feature was its head. Rather than having a single solid skull, Titanichthys had a cranium built from numerous bones that were only loosely joined together, resembling, to some extent, the skull structure of a snake. This unique design gave its jaws remarkable flexibility, allowing the mouth to swing open to an exceptionally wide angle in an instant and clamp shut with extraordinary speed. Scientists have even discovered prey inside a Dunkleosteus stomach that measured nearly half the predator's own body length. In other words, this fish could gulp down prey, roughly the size of a human in a single bite. Even more unsettling are the teeth of the conodont. Its mouth is packed with sharp, needle-like fangs, and at the very front sit two saber-like teeth. Much like switchblades, these teeth could extend and retract. As the animal swallowed its prey, the fangs drove deep into the victim's body, leaving their prey with virtually no chance of getting away. If Dunkleosteus functioned like an enormous pair of shears, then the conodont resembled a barbed black hole, drawing victims in with deadly efficiency. Yet even that was not the strangest predator of the age. Devonian oceans were also home to arthropods known as sea scorpions. Scientifically classified as Eurypterida. Magnified many times over, they resembled a massive wedge. The largest species, known as Dunkleosteus, could grow to about 2.5 meters in length, and weigh even more than an adult reindeer. Imagine a scorpion stretching 2.5 meters long. Some of these sea scorpions also possessed enormous pincers, powerful enough to crush the bones of their prey. Some species had a sharp structure at the tip of the tail, which may have delivered venom. Others developed blade-shaped tail sections powerful enough to cut prey in two. More alarming still, these sea scorpions were not limited to the water. Certain kinds could even drag themselves onto land. That meant in the Devonian period, escaping a Dunkleosteus did not necessarily mean you were safe. Even if you managed to crawl onto the shore, a 2-meter-long sea scorpion could still pull you back into the water, and keeping your distance from the ocean wouldn't guarantee safety either. If you ventured into inland rivers or lakes, danger would still be waiting. The Devonian marked the time when Earth saw the rise of its first true monsters in freshwater environments. One such animal was a Dunkleosteus-like lungfish, roughly as large as the biggest bull sharks. Yet, equipped with teeth nearly twice as long, it inhabited especially murky waters where visibility was poor, and relied on specialized sensory organs to locate nearby prey. Even more striking, some freshwater fish had also evolved strong, muscular pectoral fins. This allowed them to launch themselves from the water and seize animals right off the shoreline. Put simply, during the Devonian period, nowhere was truly safe. Whether you were in the ocean, along the coast, or beside a river, you could easily become prey. So what ultimately brought these formidable predators to an end? The answer lies in a major mass extinction event. Around 372 million years ago, at the close of the Devonian period, Earth experienced a major mass extinction, rather than a single sudden event. This crisis unfolded over millions of years, and involved several distinct waves of catastrophe. Even today, scientists have not reached a definitive conclusion about what caused it. Some researchers point to intense volcanic activity, while others suggest an asteroid impact may have played a role. Some researchers argue that widespread ocean hypoxia, likely linked to the rapid spread of land plants, was the main driver of this crisis. Others have even proposed a more dramatic explanation. Radiation from a nearby supernova may have wiped out much of marine life. Whatever the exact cause, the outcome was catastrophic. Around half of all species vanished during this extinction event, including every Dunkleosteus, all conodonts, and most sea scorpions. The creatures that had ruled the seas for roughly 50 million years were erased in what geologically speaking was only a brief moment. Yet their story did not end completely. During those same 50 million years, our own ancestors, the earliest tetrapods, were fighting to stay alive in the shallow seas and river systems of the Devonian period. And with every narrow escape from a hunting Dunkleosteus, every close call with a sea scorpion's claws, etched lasting marks into their nervous systems. Over countless generations, those traces were inherited, gradually shaping the ancient fear circuitry embedded in your brain. So when you stand at the edge of the ocean, and a sudden shiver runs through you for no clear reason, there's nothing unusual about it. It isn't simply your own fear, it's your DNA echoing a warning from the distant past. Around 400 million years ago, something in these waters was large, swift, and deadly, and your ancestors were among the rare survivors. That helps explain why thalassophobia, the fear of deep water or the ocean, is so widespread among people. In a sense, it may feel less like fear, and more like an ancient memory passed down through time, a survival instinct, seemingly written into our genes, preserved across roughly 400 million years.